Suppose the function g is defined by, that's what all that.
Yeah.
G of x equals k square root of x plus 1 equals 0 is less than or equal to x, less than or equal to 3. Mx plus 2 plus for 3 is less than x, less than or equal to 5, where k and m are constants. If g is differentiable at x equals 3, what are the values of k and m?
So the fact that g is differentiable at x equals 3, we know it's automatically continuous. So what we can go ahead and write out is the following. It is continuous at these two equations that are equivalent to, and we're going to plug in the 3. We have k times the square root of 3 plus 1 is equal to m times 3 plus 2. And it's also differentiable, meaning I could find the derivative of these. So in this case, I want to rewrite this with the power. K times x plus 1 to the 1/2. And let's figure out what the derivative of those might be. F of x, or f prime of x. So we're going to take k, bring down the 1/2, x plus 1, and 1 less of that is negative 1/2. Is everyone okay with that? Okay? The bottom one, when I take the derivative of some constant x, it is its constant by itself. This should be in a curly bracket. So we have our m. So because it is differentiable, we know those two are also equivalent to. So let's write that over to the side. It is differentiable. So I have k times 1/2. It is at 3, so plug in 3 at the x is equal to m. So the fact that we have two different variables and two different equations, it's kind of like solving for systems back in Algebra 1. So let's see how far we can get to on the left side. Isn't all of this basically 2?
Yes.
So we have 2k is equal to 3m plus 2. Can I go on any further not knowing what the k or the m is?
No.
So we stop right there for this one at the moment. Let's go on to the next piece. This right here, what is that going to give us?
2, negative 2.
It is 2 to the power of, oh, not to the power of. Isn't that basically 4 to the power of negative 1/2? And technically that is 1 over 2.
How'd you get that? You just know that? Oh,
If I bring this to the bottom, we have 1 over square root of 4. 1 over square root of 4 is 1 over 2. Okay? So we have k times 1/2, and what we just found another is 1/2, is equal to m. So we know k over 4 is equal to m. So now I know k has to be 4m. So let's see where I can plug that in. I see my k right here. It is 4m. So let's plug it in. 2 times 4m is 3m plus 2. That's going to give us 8m is 3m plus 2. And if I go ahead and put the m's together by subtracting 3m, I believe our m is 2/5. Are we all set with that one? Now we can plug in the m into this value right here. So our k is equal to 4 times 2/5. Can I leave it like this and not simplify further? Yes, on the free response, leave it just like that. If you want to go ahead and multiply it out, go for it. But if we did, what would this give us? 8 over 5. Okay, the next one that was asked was 25b. Okay. Did the cosine get you on 25b?
Yes.
Oh, goodness. All right, on 25b. Kate, let's read.
For x is not equal to 0, express f prime of x as a piecewise defined function. Find the value of x for which f prime of x equals negative 3.
So we're doing the same thing as 24c, except this time we have our trig function. So the first thing we need to do is find the derivative. So to find the derivative of the original function, what's the derivative of sine? Cosine. And I need to take the coefficient with me. Sine of x, cosine of x, I mean. And that's when, on the next one, what's the derivative of e to the negative 4x? It was that times the derivative of the power. What's the derivative of the power? Negative 4. So then I'm going to go ahead and set them equal to each other, but this time plug in what number? not plug in, we're gonna set them equal to -3. So our first condition is -2 cosine of x is equal to -3. My second one is e to the -4 x times -4 is equal to -3. When I divide it by -2 on both sides, our negatives cancel out, right? So we have 3/2. Is this calc or non-calc? Oh, non-calc. What was the ratio of all the cosine? What over what? Adjacent over hypotenuse. What is odd about the value of hypotenuse compared to the adjacent?
It's smaller.
It's smaller. Can it be smaller?
No.
So this is not possible. That's not even part of our solution. And then going on to the next one. My variable is at the power, correct? Now, before I even talk about the power, I should divide it by -4. So we have e to the -4x is equal to 3/4. So when your variable's at the power and you have our e, we did natural log on both sides. And the good news about the natural log is it's got an understood base of e, and I can cancel this out and drop the 4/-4x. Then I have natural log of 3/4 on the other side. And the last step is to divide it by -4 on both sides to make x by itself. It looks fancy, but that's what they want. That's a 4.
Is that it?
That's it. At that value, it's going to work out. Okay? So are we okay with this concept though? Okay? Just a little random reminder. We wanted all of 6, right?
26, yeah.
All of 26. Thank you. So we're looking at, is G continuous at -3? So if y'all remember our card number 1 of the year, we had to figure out what is my left limit, the right limit, are they the same? And then we had to figure out, does the point exist? And if they agree, yes, it is continuous. So let's take those rules that we did back long time ago. Step 1, the limit as x approaches the -3 from the left side. Now, from the left side is going to be this one. That's from the right side. Oh, y'all can't see. So my left side says f of x, so I'm going to go to this function and plug it in. Square root of 25 minus -3 all squared. That's going to give us 25 minus 9. Is that right?
Yes.
And 25 minus 9 is square root of what?
5 minus 3.
16?
Oh, yep.
Okay? And we know square root of 16 is 4. So my hope is that the other limit is going to reach the same value. So limit as x approaches a -3 from the positive side is x plus 7. So we have -3 plus 7. What is -3 plus 7? 4. So the fact that they're matching, the limit does exist as x approaches 3 in general of g of x to wrap it all up. Oh yeah. So that was step 1. For step 2, let's see if the point exists. Does a point at -3 of g of x exist? And -3 is part of the top function, and top is a square root function with the f of x. And we know that was already 4. They are matching. So we can now say, on my third, the limit as x approaches a -3 of g of x is a value at g of -3. Y'all remember the therefore symbol?
3 dots.
3 dots. So therefore, g of x is continuous at x equals -3.